Thanks for watching again. Mr. Weiser here. This is EOC review number 4, part 2, long division of rational expressions and multiplying and dividing rational expressions using simplification techniques. I will show you as much as I can using Desmos to check your solutions as well. Here are the standards in the Math 3 course of study if you are interested. Here is some just tips to go forth when you're doing long division and rational expressions. I'm not going to go over these. I'm just going to get right into showing you how to do one long division. But if you'd like to pause this and write down that example or write down any of this information, that is fine with me. All right, so how do I do long division? Well, first thing I'm going to do is I'm on the EOC. I'm timed. I'm going to graph this, and I'm going to see if I can get the answer first. So let me show you how to do this without doing long division first, and then we'll go back and piggyback it up and show you the long division method for those that need it and need to put work down so that way you can go back and study it. Now you have the link to this this handout on the video, of course, so you can print this out if you'd like to, so you can look at the problems. On Desmos, I have the original expression graphed along with my 4 answer choices in order of A, B, C, D. I'm just going to go down the list. Nope. 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 And bingo. So I know answer choice D is my answer. Didn't lift the pencil to do that. You can do that on the EOC. Now, you might get questions that asked, what's the next step? What do I do? So I have to show you the steps on there just to cover my bases, make sure that I can show you how to get that by hand and show you work in steps. Here's how we do it. The initial setup on this is going to have you substitute a gap, a 0x squared in there, since there is no x squared term. We'll write it out. The outside 2x minus 2. Inside the house, we'll put the 6x cubed plus 0x squared plus 8x minus 10. The next thing we want to do is we want to look at the first term. How many times does 2 go into 6? 2 times 3 is 6. And then x times what x with an exponent is going to give you x cubed, and x times x squared is going to give you x cubed. So that's going to be what you multiply that by. Next thing is we'll times that by the numbers on the outside. So 3x squared times 2x is 6x cubed. And 3x squared times negative 2 is minus 6x squared. Next step is going to be to subtract down. So by subtracting down, we're basically switching the signs, canceling that first term out, meaning that minus a negative is actually going to be plus. So 6 plus 0 is going to be 6x squared. And that's why we have that placeholder. Bring down the next term, repeat the process. So how many times does 2x go into 6x squared? Well, 2x goes into 6x squared 3, but it's only going to have 1x because that's an x squared and that's an x. So 3x gets multiplied by 2x again. That's going to give you 6x squared. 3x times minus 2 is negative 6x. And we're going to subtract down once again. And that's going to give you canceled out. A negative negative is going to be a plus. That's going to be 14x. Let me write that in green to be consistent. So 14x. Bring down the minus 10. And let me go ahead and move that up for a minute. All right, so now I'm going to bring down that minus 10. We're going to repeat that process one last time. How many times does 2 go into 14? 2 goes into 14 7 times. So there's your 7. X goes into x once, so just 7. 7 times 2x is 14x. 7 times negative 2 is minus 14. And we'll do one more round of subtraction to get a remainder. That's going to cancel out these 14s again. And once again, a negative is going to turn into positive. So negative 10 plus 14 is 4. That's your remainder. And so we write our expression with the divisor or the quotient up here, sorry, first. So we say 3x squared plus 3x plus 7. And then we do our remainder, we do plus your remainder on top of your divisor. Your divisor is what you divide by. And so that's going to give you choice D, which we had gotten with the graph already. All right, write that down and go to the next question. All right, part 2, number 2, we want to simplify the following expression. This looks like another division problem, but if you look at your answer choices, It doesn't line up to be like a long division or synthetic division. So this question is going to be more along the lines of how do we factor this and simplify and cancel things out? Once again, can you use a graph to get your answer? Sure. So I want to just kind of warn you about when you're typing in something like this, always throw I do my division sign first. That way I can type my numerator. And then just arrow down and type my denominator. And I don't have to worry about like errors when I type it. I'll get my graph here. And then I can compare my graphs from there. So why don't you try that? Pause it first, see if you can type that in, type your answer choices in, and find the one that matches it, get your answer. Then I'll show you how to do it by hand. All right, have you gotten them all typed in? If so, you can look at my graph here. I got my answer choices keyed in, my original graph shown. One at a time. No, that's not going to work. B is not going to work. C doesn't work. So once again, answer choice D lines up with our first graph. So let me show you how to do that by factoring. When you're doing a factoring, the rule is you always want to find the greatest common factor first, if at all possible. So if you look at your numerator, is there anything that I can divide out? And they certainly look like they have even numbers, and they all have an x. So I'm going to actually factor out a 2x from both of those, since an even number is divisible by 2. That's going to give me 2 divided by 2 is 1, so x cubed divided by x is x squared. And then 12 divided by 2 is 6. Take the x squared out, it's just x. And 18 divided by 2 is 9. And since the x is gone, that's your numerator. Now that can be further factored. Let's go to the bottom. These are both divisible by 4. Can't take an x out, so x squared minus 36 divided by 4 is 9. So from there, I'm going to be able to factor the x squared plus 6x plus 9. If you don't remember some factoring rules, for a simple trinomial like this, you just want to look at the middle number and the last number. The last number is going to be, what can I get to multiply by to give me 9? And then what same numbers can I add together to get me the middle number, in this case 6? So it turns out that 3 times 3 and 3 plus 3 will do the trick. So that middle, or that set of parentheses, is going to be x plus 3 and x plus 3. X plus 3 times x plus 3 will give you x squared plus 6x plus 9. Don't forget you also have a 2x on the outside, so that's going to be your final form of the numerator. The denominator, x squared minus 9, well, the middle term is 0. So again, what multiplies to negative 9 and adds to 0? Well, let's see, 3 times negative 3, 3 plus negative 3. That's also just a difference of 2 squares. So you can also write the 4 on the outside and just do x plus 3 and x minus 3. So I'm going to rewrite this as 2x, x plus 3, x plus 3, x plus 3. And then on the numerator, I'm going to do the 4, x plus 3, and x minus 3. And now I can cancel things out. So I have an x plus 3 factor that'll cancel out. And I also have this 2 and 4. See, 2 over 4 reduces to 1 over 2. So that's actually going to be 1/2. And so that's why you see this 2. You don't see a 1 there because you don't need to write the 1. But 1x, x doesn't go away. And then you have x plus 3, 2, x minus 3. That'll be your simplified answer. All right, let's go to number 3. Number 3 is a division problem, which expression is equivalent to x plus 7 over x squared plus 4x minus 2 divided by x plus 5 over x squared plus 8x plus 15. You can key it in as a division problem, but you got to be careful how you do that. Let me walk you through how I key it in as a division problem. I start with putting parentheses around each expression. So I'm going to, we'll put parentheses around here and here. Then this is just your slash button, okay? So when I'm doing that, when I'm keying that in, I'm going to parentheses, I'm going to hit the fraction bar and do x plus 7 over x squared plus 4x. There's 4x minus 2. And then I hit the division bar. And then I do another set of parentheses and hit a fraction bar one more time. X plus 5 over x squared plus 8x plus 15. That's not the only way to do this, but that's kind of the way I approach these problems. If you don't like having a fraction divided by fraction, just do keep, change, flip. So you can do the same thing, but you can do this fraction, and then you can times it by the reciprocal. So if I do x squared plus 8x plus 15 over x plus 5, as you can see, that's going to give me the same graph lined up no matter how you do it. So it's kind of personal preference. When you're doing it by hand, of course, you need to do keep, change, flip anyway. So it's not going to hurt you to do that, but either way is fine as long as you're careful with how you key that in. So if you want to try that and key in your answers, just a word of the wise. If you have a number by itself, then you have to do y equals that number if you want to see the graph. All right, so here are my answer choices for either the keep, change, flip or the original. If I reveal them, the first one is a little bit off, so I'll hide that. The second one, hold on, I think I typed something wrong, so hold on one second. Well, I have a typo in here, so I'm going to fix that right now. Hopefully what I shared with you will be updated. That should be a 21, not a 2. So if I go in here and I actually change that to a 21, then I can match up my graph. So 21 here, let's take a look. So looks like answer choice A is the winner. And these two are just flat lines, so that's not going to work. So sorry about that, but it should be x plus 3 over x minus 3. Now let's go over how to solve that problem by hand. So the first thing we want to do is we want to factor, but before I factor, I got to keep, change, flip this thing. So I'm going to go ahead and rewrite this as a multiplication. So we're going to keep this, change that to times, and we're going to flip, keep, change, flip, which means I want to write the reciprocal of that. So I'm going to rewrite that as x plus 7 over x squared plus 4x plus minus 21, not 2, and then times it by x plus 5, x squared plus 8x plus 15 divided by x plus 5. All right, so now I want to factor. What multiplies by, what two numbers multiply to negative 21 and add to positive 4? So multiply by negative 21, add to 4. 7 and 3, which one's negative? It's going to have to be negative 3. So they multiply to negative 21, add to positive 4. It's going to be 7 and negative 3. So your factors are x plus 7, x minus 3. Over here on the numerator, what multiplies to 15 and adds to 5? Or 8. Got a little ahead of myself there. Well, it's going to be 3 and 5. So x plus 3, x plus 5. Let me rewrite this so it doesn't look so ugly. So it's going to have x plus 7 on top of your factored form, x plus 7, x minus 3. And then I have times my factored form, x plus 3, x plus 5 over x plus 5. And now I can cancel away. So these x plus 7s are gone. These x plus 5s are gone. What am I left with? X plus 3 on the top divided by x minus 3. And there you have it. Answer choice A. All right, write that down. Go to the next question. All right, at this point, this one's very similar to number 3. You should try this one on your own, whether you want to use graphing technology or simplifying and factoring. Give it a shot, pause the video, then you can unpause it. I'll work it out. All right, hopefully you have gotten a chance to key this in. These are my original expression. I'm not going to bother keep changing and flipping. Just use parentheses and be careful with how you key that in. I have all my answer choices. Let's see which graph is going to line up with that most appropriately. So I'm not seeing that. Oh, it looks like it's the same graph. Looks like A is the answer. It's definitely not B, C, or D. So I have my answer. My answer is going to be A. And these numbers just represent restrictions. Remember, restrictions are numbers you're not allowed to plug in. They give you 0 on the denominator. Now, I'll talk more about that when I show you how to do this by hand. So let me first do this as a keep change flip and flip this and rewrite it. All right, so I have it rewritten. Now I'm going to factor it. I'm not going to walk you through each factoring step, but I'll show you my factors. And if you're not sure about the factors, reach out to me or somebody, and I can kind of go through them in a little bit more further detail if you need to. All right, in the blue, you'll see the factored form of each of those expressions. The top two are difference of squares, so positive and negative. And the bottom two are actually perfect square trinomials, so you'll see the same number. 3 times 3 is 9, 3 plus 3 is 6, 2 times 2 is 4, 2 plus 2 is 4. So it actually works out pretty nicely. I'm going to go ahead and cancel factors out. You can see I have a pair of x plus 2's that'll cancel out, one on the left side, one on the right bottom side. And the same thing with the x plus 3's. This is one big multiplication problem, so you can get away with doing that. That'll cancel out here, and that'll cancel out there. So your final answer is just going to have what's remaining. I'm going to write my numerator, x minus 2, x minus 3. That's what's left on the top. And then on the denominator, I have x plus 3 and x plus 2. And so remember, that was the same thing as what we got here. Now let's talk about these restrictions. I know you didn't really need them to be able to answer the question. But as far as getting the restrictions, it's just what makes your denominator equal to 0. You cannot divide by 0, so x cannot be negative 3. So negative 3 gives 0 for both of those factors. X can also not be negative 2 because that gives you 0. But also up here, because originally this was over here in the denominator, you can't also have zeros for these factors. So x cannot equal negative 3 for that. Well, we already got that down here. But x can also not equal 3 because 3 minus 3 is equal to 0. So you have like 3 restrictions, positive 3, negative 3, and negative 2. And that's where those numbers are coming from. You are not able to divide by 0. When you do, you get an error. It's undefined. All right, write that down. Let's go to the next question. This should be the last one on this video. All right, this is going to be more geared toward what the graph looks like. This is actually a multi-part question. The question wants to know, what are the restrictions? How many points of discontinuity are there? And what is the removable and non-removable point of discontinuity? So let me just do a real quick thing. Remember, the denominator cannot equal 0. So you want to know what's going to make that equal to 0. So you can actually, if you want, you can just use Desmos or you can factor. Let me show you a Desmos hack on that one. Let me get my other one out of here. For that, just take your denominator, type it in, find your zeros. Shoot, I have that right. 2x squared, oh, it's a 5. That's more like it. So I have two numbers that actually are no-goes. My restrictions, x cannot equal negative 3, and x cannot equal positive 0.5. And so my domain would be all real numbers except those two values. How many points of discontinuity are there? Same thing. There are 2 of them. So the 2 restrictions are your points of discontinuity. So your restrictions, x cannot equal those numbers. There are 2 points of discontinuity, and those are the same thing. Which one is removable? Well, you can go through and you can actually graph the whole function to determine that. So since I know x cannot be negative 3 or 0.5, let's graph the entire function. Well, once again, we found another typo. I got to fix that. So that's going to be an x there. So the removable point of discontinuity, we can find that here. I'll show you. Let me just put that x back. It's kind of hard to see here, but I'm going to do an x equals so you can see the 2 points of discontinuity. Now the first one here, x equals -3, it actually goes through the line, so it's not removable. It actually hits, looks like it hits that graph there, but the one at 0.5, it avoids that. That's actually called a vertical asymptote. So the removable point of discontinuity is actually going to be -3, excuse me. That means the non-removable point, which is what we call the vertical asymptote, is going to be x equals 0.5. Now let me show you how to do all those by hand. It's going to involve factoring, canceling out, and all that stuff. So let's go ahead and write all those down first. And here's how we do it. First, we want to factor both the numerator and the denominator. So the numerator is just going to have a GCF to start with. So that's going to be x squared minus 2x minus 15. If I pull that x out, remember that was a typo, so there should be an x. Hopefully it's fixed on the solution or the link that I provided in the video. And then on the denominator, that's going to be an AC method. So we'll have to do a little bit more involvement with that one. But for AC, you want to multiply a times c. So 2 times -3 is going to be -6. And we want to think about two numbers that multiply to -6 and add to the middle number. And so that's going to be, let's see, +6 and -1 should work. And so what we do for that middle, or that bottom thing, is we rewrite it as 2x squared plus 6x. We split this up for x and x, minus 1x minus 3. And then we do a GCF of the first two and the last two. So the first two is going to be 2x, and then x plus 3. And the last two is going to be -1, and that'll take that negative out, so it's also x plus 3. So your factors are going to be 2x minus 1, and the x plus 3 that's repeated is just going to be one factor. And so that's your denominators factored. The numerator is going to have just a simple trinomial, so what multiplies to -15 and adds to -2, and that's going to be 5 and 3, I think, where the 5 would be negative. So that's going to be x minus 5, and x plus 3. It's quite messy, but let me rewrite this function in factored form. So follow me down here. F of x is going to equal, on the numerator, you'll have the GCF that's out here. So don't forget the GCF, x. And then you'll have your x minus 5 and your x plus 3. Your denominator will have the two factors here, 2x minus 1 and x plus 3. And now I can explain the removable and non-removable part. So with removable, what would cancel out? Well, I have an x plus 3 and an x plus 3. So that number, that restriction on the denominator, x cannot equal -3, well, that cancels out. So that's a removable point. Removable, cancels. The non-removable is just what's left over. So x cannot equal, if you solve that for 0, you get 1/2. So the non-removable is going to be x cannot equal 1/2. So 1/2, that's a vertical asymptote. So -3 is called the hole in the graph, and 1/2 is called the vertical asymptote. That's a lot to unpack on that question, but that concludes this video for part 2. The next video is going to involve the rest of the review number 4. And that'll be over rational expressions, adding and subtracting and solving equations. Thanks for watching, guys.